Hello, this is Mrs. Ward, and I am going to go over the notes from section 8.1, exponential functions, and we're going to take the derivatives and integrate the exponential functions. So we have done derivatives in the past, and we have done integration in the past, and we just did a quick review on exponential functions. And so now what we're going to do is we're going to take the derivative of exponential functions and we're going to take the integral of exponential functions. To start off with, we're going to start with e, the base of the natural log, and we're going to go over how to take the derivative of anything of e raised to a power. So when I have e and I'm taking the derivative, I am just going to write that as e to the x. In other words, what you see here is the derivative. It does not change. But when I have e raised to a function, so that's this u here, when it's raised to a function, I'm going to basically do the same thing. I'm going to copy down e to the u, and then I'm going to multiply it by the derivative of that function. So let's do one. So if I find the derivative of e raised to the 1 minus x power, to take the derivative, I'm following this pattern here. So I'm going to do, the derivative is going to be e to the 1 minus x. I just copied down what I saw there before. And now I'm going to look here, and I'm going to take the derivative of 1 minus x, which is just going to be negative 1. So my final answer is going to be a negative e to the 1 minus x. And that's it. Just, it's really that quick and simple. So the next one, I have e to the x squared over x, and then I put this note here that we're going to have to remember to use the quotient rule. And I don't know if you remember the quotient rule, but if I have f of x divided by g of x, remember we leave our denominator alone, take the derivative of the numerator, then we subtract, leave the numerator alone, take the derivative of the denominator, all over the denominator squared. So that's a recap of the quotient rule. So now I'm going to apply that to this function right here. So to take the derivative, I'm going to leave my denominator alone, so I'm going to leave that x alone. I'm going to now take the derivative of e to the x squared, so that's e x squared, copy it down. Then remember, I look here and I ask myself, what's the derivative of x squared? And that's going to be 2x minus, now I leave the e to the x squared alone, take the derivative of x, which is just 1, and I'm going to put this all over the denominator squared. So when I do that, I realize that in my numerator I have e to the x squared, so I'm going to factor that out. So I'm going to have e to the x squared. I'm factoring that out because that's here and that's here. And what I'm left with is x times 2x, which will be 2x squared, minus just this 1, all over x squared. And then I look and see if anything can be simplified, and I don't think so, so that is going to be my final answer. Moving on to the next one, I have g to the x, and I'm is equal to 1 minus e to the negative x squared. So I'm going to, this note over here is telling me that I have to use the chain rule. Remember, the chain rule says that you take the derivative of the outermost function. So right now, the derivative of the outermost function is going to be raising something to the second power. So to take the derivative of something being raised to the second power, I'm going to take 2 times whatever I'm raising to the second power and decrease this power by 1. So that's now going to be the first power. Then the chain rule says that you look inside, so now I'm looking inside to this 1 minus e to the negative x, and I take the derivative of what's inside. The derivative of this 1 is 0. I'm going to write that just so you know what I'm doing. Here's that minus sign. The derivative of e to the negative x is going to be e to the negative x, and then I look at here and I take the derivative of that negative x, which will just be negative 1. So then when I have this, I'm going to have 2 times 1 minus e to negative x. I'm not going to write that 1 anymore. And then this negative times a negative will be a positive. So this will be times e to the negative x. And just to make it look a little bit neater, I'm probably going to bring that e to the negative x up in front. 2 times e to the negative x times 1 minus e to the negative x. No need to distribute. I'm just going to leave it like that. Number 2, use implicit differentiation to find the derivative of y in terms of x of that. So remember when we do this, anytime I take the derivative of y, I'm going to write dy dx. And then I'm going to take everything with the dy dx on one side by itself. Everything else will go on the other side. And then I'm going to solve. So let's go term by term. So to take the derivative of this, I'm going to have to use the product rule. So to use the product rule, I'm going to leave the x alone, take the derivative of e to the y, which will be e to the y, and now I have to take the derivative of this y, which will be 1 dy dx. So this whole thing is the derivative of that term there. Then I'm going to do a product rule. I'm not done. So then I'm going to do plus, and then take the derivative of x, which is just 1, and then leave that e to the y alone. So now that's this whole derivative. Now I'm going to take the derivative of this negative 10x, which will just be minus 10. No need, I could write dx, but I'm not going to. And then I'm going to have plus, and then the derivative of this 3y is going to be 3 dy dx, and that's still going to equal 0 because the derivative of 0 is 0. Anything with a dy dx, so there's two things with dy dx. This has a dy dx, and this has a dy dx. So I'm going to leave these two on this side by itself. So I'm going to have I'm just writing. And then anything that does not have the dy dx, so this here and this here, I'm going to take to the other side. So I'm going to have 10 minus e to the y. Then I am going to factor out this dy dx. So factor this out, factor this out. So I'm going to have dy dx is equal to the quantity of x times e to the y plus 3, and this is equal to 10 minus e to the y. And now to solve for dy dx, I'm going to divide both sides by this quantity. So my final answer is going to be 10 minus e to the y all over x times e to the y plus 3. And remember, you could have it in a different order. You just need to check and make sure that your signs are correct. Okay, find the relative. The next one says find the relative extrema and inflection points. So just a reminder to find the relative extrema. That means I'm finding the relative min and or max. To do that, remember you take your first derivative and you set equal to 0, or your first derivative is undefined. To find the points of inflection, I am going to take the second derivative, and that's going to equal 0, or the second derivative is going to be undefined. So I am going to have to look at this function, and I'm going to have to take the derivative of that. So the first thing I'm going to do is I'm going to rewrite the function because I don't want to deal with that 2 in the denominator. So I'm going to bring that out, factor that out, and make it 1/2 times e to the x plus e to the negative x. Now when I take the derivative, the 1/2 will just stay here. Going term by term, the derivative of e to the x is e to the x. The derivative of x is just 1 plus e to the negative x. That's the derivative of e to the negative x. And then the derivative of negative x is negative 1. So when I have this, I am going to just rewrite this as 1/2 e to the x minus, because of that negative sign, e to the negative x. I'm going to first set this derivative equal, whoopsie, just one derivative, set this derivative equal to 0. And when I do that, I'm going to have 0 is equal to 1/2 times this parenthesis. Then I am going to have multiply both sides by 2, so it's still going to be 0. Now, since they're set equal to 0, I'm going to bring this over here. So I'm going to say e to the negative x is equal to e to the x. They have the same basis, so I can set the exponents equal to each other. I'm going to add x to both sides. So I'm going to have 0 is equal to 2x, x is equal to 0. So that is one place where the derivative is equal to 0, is when x is equal to 0. Then I'm going to ask myself, when is the derivative undefined? And that would be never. It has a domain, so this does not apply. So now I am going to go back to this point here, which is 0. I'm going to pick test points. So let's say I pick -1 and I pick +1. And then I'm asking myself, when is the derivative positive? So when is what is the derivative of f of x? So if I put in a -1, so I'd have e to -1 minus e to the +1, and that ends up being a negative number. And then when I put 1 in and I take e to the first, that's going to be the same thing, and that's, oh no, that's going to be positive. So that'll be positive. And I just threw those in my calculator if you wanted to know. And so then I am going to say that my function is decreasing here, and then it's increasing here. So if you want to picture it, you're decreasing, then you're increasing. So at 0, I am going to have a relative min. To find that relative min, I am going to find f of 0. Going back to the original function, I'm going to put 0 into the original function, which is way up there. So I'm going to say e to the 0 plus e to the -0, which is just 0, all over 2. Well, anything raised to the 0 power is 1. So I am going to have 1 plus 1, which is 2. So I'm going to have 2 over 2, which is 1. So my relative min is going to be the order pair 0, 1. So the relative min is going to be that 1. Now to find the inflection points, I am going to go up to my first derivative. And here is my first derivative. I'm going to highlight it for you. And I am going to take the derivative of this to find my second derivative. And I'm going to switch colors and go over here. So to find the second derivative, I'm still leaving that 1/2 out there. Now I'm going to take the derivative of e to the x, which would just be e to the x times 1, minus the derivative of e to the negative x is e to the negative x. The derivative of negative x is -1. So my second derivative ends up being 1/2 times e to the x plus e to the negative x. Then I want to find the places where it is equal to 0. So to do that, I'm going to have 0 is equal to 1/2 e to the negative, or e to the x plus e to the negative x. Multiply both sides by 2, and I'm going to get 0 is equal to e to the x plus e to the negative x. So subtract, so I'm going to have opposite of e to the negative x is equal to e to the positive x. So I'm going to have a -1 here, then times negative x is equal to x. So I'm going to get x is equal to x, subtract x from both sides, and I'm going to have 0 is equal to x is equal to 0. Then what I'm going to do is that to find the second, where the second derivative is undefined, is I'm going to look up here and I'm going to, this is, the domain is all real numbers, so this never happens. To find the inflection points, I'm going to take that 0, whoopsie, I'm going to take that 0, and I want to pick a test point, so I'm probably going to pick -1 again, and I'm going to pick +1, and now I'm going to do the second derivative of -1, and when I put that in my calculator, that ends up being positive. When I do the second derivative of +1, putting that in my calculator, that ends up being a positive. So that means that I'm concaving up here, and I'm concaving up here. Since I'm not switching directions, there is no inflection point. Remember, you have to go from concaving up to concaving down, or concaving down to concaving up to have an inflection point. Moving on to the next one. So now we did the derivatives. Now we're going to do the integration. Remember, integration is the antiderivative. So the antiderivative of e to the x is just going to be e to the x plus c when I have this indefinite integral. Remember, when I have a lower bound and upper bound, the c goes away and I have to substitute in those numbers. When I'm doing the integration of e to the u plus c, remember, this means I'm going to have to do that u substitution when necessary. So we're just going to have to remember that. And on this one, I technically should have written f of x, f of u. Okay, so let's try some. So if I have this one, if I'm raising e to any other power than x, I'm going to have to do that u substitution. So remember, I'm going to say u is equal to negative 2x, and then I'm taking the derivative of u, which will be negative 2 dx, and then I go up and I see that I have that dx, so I'm going to make this negative 1/2 is equal to dx, or du is equal to negative 1/2. Now I substitute in. So when I substitute in, remember here, my u is this negative 2x. So this will be e to the u, and then the dx is equal to this negative 1/2 du. So then I'm going to have negative 1/2 du. Now when I take the antiderivative, I have it all set up. I am going to just do e to the u. So e to the u plus c. So now I'm going to replace my negative 2x. So negative 1/2 e to the negative 2x plus c. And I'm going to say that that's equal to f of x. And that's it. That's all I do. So, okay, when I go to do this one, remember, if e is raised to any other power but 1, so this e is raised to the x to the third over 2, that is going to have to be my u. So u is going to be x to the third over 2. So I'm going to rewrite that as u is equal to 1/2 x to the third. Now when I take the derivative of that, that's going to be 3 times 1/2 will be 3/2 x squared dx. I see when I go up here, when I'm looking, I have the x squared dx. So I'm going to have to take that 3/2 to the other side. So I'm going to divide. So I'm going to have 2/3 du is equal to x squared dx. Now I can do that sort of substitution in. So when I do that, this will be e to the u and then 2/3 du. So then when I take the antiderivative, I'm just going to write 2/3, bringing that up front, e, replacing that u back with the x to the third, 2 plus c. That's good for that one. Moving on to the next one. I have this, so I am going to rewrite it first and make this 5 minus e to the x, and then times e to the 2x. Negative 2x, because I brought it up from the denominator. And then I decide to distribute this. So I'm going to have 5e to the negative 2x minus e. And when I multiply, I add exponents. So this is going to be negative x. And I'm going to take the derivative. So that's, I want to do dx there. And when I do that, I am going to go separate it term by term, because that made... So I'm going to have to do the u substitution. I'm doing two separate problems, really. Well, two parts of a problem. So when I look at this, I have this being raised to power. So I'm going to say u is equal to negative 2x. So the derivative of u is going to be negative 2 dx. So negative 1/2 du is equal to dx. So this negative 1/2 will be what I put in for the dx. The 5 will stay there. This e will be e to the u. So when I write this part, I'm going to have the 5 e to the u negative 1/2 du. And so when I take the antiderivative of this, I'm going to multiply. So this will be negative 5/2 e, and I'm going to put the x back in, negative 2x. And then I'm just going to write plus c. I know I'm going to take care of that in a second. So let me go back up and do the other half. So here's this minus sign. So I'm going to copy down this minus sign so I don't forget it. All right, and then here I'm going to have this is going to be my u. So u is going to equal negative x. So the derivative of u is going to equal negative 1 dx. So negative du is equal to dx. So when I go to do that, the dx is going to be this negative du. So now when I go to write that, this is minus, and then I'm going to do negative 1 e to negative x. I should have left it as a u. Let me leave it as a u. U du. And then this will end up being negative e to negative x. And then this will be plus plus. So then my final answer is going to be f of x is equal to negative 5/2 e to the negative 2x plus e to the negative x plus c. Okay, that's everything. Yeah, so when you have one like this, you're going to have to separate into two integrals. You're going to have to do the u substitution twice. Just go slow, take your time, make sure you write everything down. Number 5, find the particular solution of the differential equation that satisfies the initial condition. So it's telling you that the second derivative is equal to that. It's telling you that at f is equal to 0 is 1/4, and then the derivative at 0 is 0. So it's giving me the second derivative. So to find the first derivative, I'm going to have to take the antiderivative of this. So the first derivative is equal to the antiderivative of the second, is what I'm trying to say solely. So I'm going to say to find the first derivative, I'm going to take the antiderivative of that x plus e to the 2x. So when I go to do that, I can do it all at once. I think we can. So the derivative, the antiderivative of x is going to be 1/2 x squared. Then to do the e to the x, I'm going to say that u is equal to 2x. So du is equal to x, 2x dx. Ooh, just 2 dx. So 1/2 du is equal to dx. So then this will be plus e to the u times 1/2 du. So I'm going to have x squared over 2 plus e to the 2x over 2 plus c, and this is equal to my first derivative. I think I agree with myself. And then I go back up and I see that when my first derivative is equal to 0, it's equal to 0. So I'm going to say 0 is equal to 0 squared over 2 plus e to the 2 times 0 over 2 plus c. So 0 is equal to 0 plus anything raised to the 0 power is 1. So this will be 1/2 plus c. So I'm going to get negative 1/2 is equal to c. So now I'm putting that in. So when I do that, now I have my first derivative is equal to x squared over 2 plus e to the 2x over 2 plus, oh, actually minus 1/2. So that's my first derivative. Now I want to find the original function, so I'm going to take the antiderivative of this. So taking the antiderivative of this, when I take the antiderivative, I am going to raise that to the third power, multiply it by the reciprocal. Then to do this, my u is equal to 2x. My derivative of u is equal to 2 dx. So 1/2 du is equal to dx. So the derivative of this would be e to the u over 2 times this 1/2 du. And then the antiderivative of that would just be minus 1/2 x. So I'm putting this back in before I do this. So the function would be x to the third over 6 plus e to the 2x over 4 minus 1/2 x plus c. Then it tells me that when f is equal to 0, my answer is 1/4. So my answer is 1/4 when x is equal to 0. So I substitute 0 in for x, put 1/4 in for the y. So I'm going to have 1/4. This will be 0. E to the 0 power is 1, so this will be 1/4 plus 0 plus c. So subtract 1/4 from both sides. And when I do that, I get 0. That's a c, is equal to c. And so then my final equation, my final f of x is going to be 0 in for this c. So it's going to be x to the third over 6 plus e to the 2x over 4 minus 1/2 x. And that is my final answer. And then the last one, it says find the area of the region bounded by the graph e to the x. So if I graph that, I get something that looks like this. Oh, I forgot. I think I fixed it on your notes. X is equal to 0. So I'm bounded by the y-axis. I'm bounded by x is equal to 0 and x is equal to 5. So this is the area that I'm trying to find underneath the curve. So I'm doing the antiderivative of e to the x. My lower bound is 0. My upper bound is 5. So now e is being raised to the x. So when I take the antiderivative, I'm just going to write e to the x and then 0 to 5 is my upper bound and my lower bound. So I'm going to say e to the 5th minus e to the 0. Well, e to the 5th, I'm just going to leave like that. Anything raised to 0 power is 1. So I could leave it like that, or I can find the decimal, which is 147.413. All right, I hope this helps, and I'll see you next time.